Alright, last example 5. We're gonna study how to really find the total equivalent capacitance and inductance for the given connections. Okay, this part will definitely be covered in future quiz as well as exam. Okay, so please pay more attention here. One for capacitor, one for inductor. But we would like to begin with inductor, which is easier. And why it is easier? Because if you review the previous slide, the rule saying the combination rules for inductor is exactly same as that for resistors. Okay. However, to capacitors is opposite. Okay. We will see how to deal with both. Begin with the circuit B. I'm repeating the circuit as this and go through the solution step by step by writing it. So how to identify the series and the parallel is the first thing that we need to figure out. Let's see what kind of series or parallel we can clearly have at first look. It's very easy, I believe. L1, L2 are parallel. Right? This is very easy. Then what else we can see? The circuit look is a little bit tricky, but if I do an equivalent redraw by rotate L5 to be vertical like this, then you should be able to immediately realize L1 to 5 are parallel. Okay. Once you identify this, then the rest of the thing very straightforward. Okay. So this parallel obviously further gonna series with L4. Right? After that, the entire thing gonna parallel L6. Right? Here. And after that, they in total series connects with L3. This is the identification of series and the parallel. We're not applying the combination rules yet, but we don't need to hurry about that. Okay, and the identification is obviously much more important. Once again, we rotate L5 in the original circuit by 90 degrees. Pretty much this node of the L5 go up to here. This is how we come up with this circuit here. And from this pink circuit, 5, 2, 1, 3 parallel, like this. And then after combining these three, the further series was down here. And then further parallel was here. And then further series was this guy. This is how we end up with this connection identification. Okay. If this is clear, then further we just apply the corresponding combination rule. Here I'm writing series. SER rather than plus. The reason is this is capacitor and the inductor we are talking about, not resistor. In resistor we know series directly means plus. However, here it's not necessary. So to differentiate a plus and series connection, I'm using this SER. Okay, but of course to the inductor it is same as its resistor rule. That's why we can write it like this. Right? Because again, series connection among inductors is same as the rule for series connection of resistors. So series is meaning plus. And then how to do the parallel? To the parallel, be careful, like in the resistor. Combine this, L1, L2, divided by L1 plus L2. Right? In other words, it equals to 1 over reciprocal of L1 plus reciprocal of L2. Right? And after this. This guy parallel with L5 plus L4, and parallel with L6 plus L3. And then further do this two parallel. you're ending up with L1, L2, L1 plus L2 times L5, and then L1, L2, L1 plus L2 plus L5. Right. This is the parallel between these two, plus L4, and then parallel with L6 plus L3. And further equals to a ratio. Numerator is the big parenthesis times L6. Denominator is the same parenthesis plus L6, and then plus L3 here, right? And no further organization is required. Okay, so you know what to do in the exam and the quiz. But if everything is specified as specific numbers, then we need to find the numbers. But if everything is in terms of symbols, we can end up with here. Okay, that's good enough. This is the solution for circuit B, example 5. Now let's take a look at the solution for capacitor, example 5, circuit A. Remember, the combination rule for capacitor is opposite to that of resistor. So saying when you combine two parallel capacitor, you need to use plus. When you combine two series capacitor, you need to do 1 over the sum of reciprocal. Okay, so with those being said, let's identify them first, series or parallel, and then we apply the combination rule. Okay, so identifying them, so we can see clearly these two parallel, series with this guy, and further parallel with this guy, and then series with these two. Okay, so it's 2 micro parallel with 4 micro, and then series with 3 micro, then total parallel with 2 micro, and then series with 3 micro, and then series the last 12 micro. Right? Does this make sense? Again, 2, 4 parallel, series with 3, further parallels 2, and then at last series with these two. So if this is clear, and then start to apply the combination rule. In the brackets, we have these two parallel. These two parallel, the rule is same as the series connection of the resistor. So 2 micro plus 4 micro. Series 3 then means what? Applied in parallel rule of the resistor, which means take times 3 micro. The denominator is 2 micro plus 4 micro plus 3 micro. Okay, this is the bracket result. Right? And this thing parallel with 2 micro, and then series with 3 micro, and then series with the last 12 micro. Right? Of course, this is equals to what? So 6 parallel with 3 equals to 2 micro. Then further parallel with 2, and then series with 3. Right? So 2 parallel with 2 equals to what? 2 plus 2. Because parallel tool is same as the resistor series, which is plus. And these result can series with 3, and then series with 12. Right? So 4, 3, 12, they are series connected capacitors. Following the rule of parallel resistors, combining these two first, so 4 micro times 3 micro, divide by 4 micro plus 3 micro. This is a 4 micro series with 3 micro. And this guy is series with the last 12 micro. And then, so these series connection result is equals to 12 sevenths. And this guy's series connect with 12 micro equals to 12 sevenths times 12. divided by 12 sevenths plus 12. And eventually the total result is equals to 1.5 microfarad. Okay, so yes, capacitor is more difficult, or say requires more patience and longer consistence of your clear logic. Okay, so you want to do some exercise to become more efficient. Okay, that's all about the examples as well as this module. So please exercise them all, repeat them, and then ask questions. Okay, thank you, and see you in next module.